Hi there, welcome to our new learning unit. So let's get ready and let's have a wonderful learning session. Let's start. Learning Unit 6 with the topic of probability of this semester 2, and the person in charge is me, Emmeline Xiao, and there is my email address and my mobile phone. In case you want to ask any question, you are welcome to WhatsApp me or email me. So for this LU6, we have 3 subtopics. The first one is events and probability, the second one is conditional probability, and the last one is Bayes' theorem. Now let's go to the first subtopic, which is events and probability. For the learning outcomes, you have to make sure at the end of this chapter, you know how to define and determine experiments, outcomes, sample spaces and events, define and determine simple events and compound events, define probability, how to find probabilities of simple and compound events, define and determine sum of events, joint event and their probabilities, define and determine mutually exclusive events and complementary events, and the last one is determine independent and dependent events. The introduction. So let's talk about sampling space and situation. We know that the primary concern in probability study is dealing with experiments. So the cases vary and of many different types. So let's have examples of experiments. The first one result in flipping a coin or tossing a die. Or another example is the examination results for a candidate. So each of the situations usually produce different results. For example, when we toss a die, we can have either 1, 2, 3, 4, 5 or 6. So each of these result is our outcome. And then the set of all possible outcomes that we can have from that experiment is what we call sampling space. And we will use this big S to represent our sample space or our sampling space. So again, for experiment, it is a process involving chance that leads to one of several possible outcomes. Sample space is a set of all possible outcomes. Some books will have this symbol and some books will have this symbol. So if you see these two symbols, this is just the sample space. And then the outcome is a possible result of an experiment. Let's look at more examples of experiment. So in this table, we can see the experiment, what are the outcomes and the sample space. So for a coin toss, we can get either a head on top or a tail on top. So this is hash T. And then when we have a die roll, so again we can have for the sample space 1, 2, 3, 4, 5 or 6. And then for 2 coin toss, we can have the first outcome, maybe we can have both coins head on top, 1 coin head on top, the other is tail, 1 coin tail on top, the other is head, and both coins tail on top. So for the sample space, where we do experiment of 2 coins toss, we will have hash hash, hash T, T hash and TT. Now let's talk about event. So event is a set of one or more possible outcomes which satisfies a given condition. So it is actually a subset in the sampling space. So for simple event is where we have a single outcome, and the compound event is an event with more than one outcomes. So let's discuss further in the next slide. Let's discuss this event by using a coin, and we toss this coin two times. Okay, so the event of getting two heads involve only one outcome, which is head and then followed by head. So this is a simple event. And then the event of getting a head only on the first toss, because we toss this twice, right? So only on the first toss involve only one outcome, that is hash t. Therefore, this is a simple event. The event of getting a head on the first toss involve two outcomes. Either we have hash first followed by hash, or we can have hash first followed by a tail. Okay, because we have two outcomes, so this is a compound event. The event of getting a head involves two outcomes: hash first followed by tail, and then tail first followed by head. As we have two outcomes, so this is another compound event. Probability. By definition, probability is the degree of certainty of an event to occur. So if it is impossible to happen, that probability is equals to 0. If it is certain to happen, so the probability is 1. It is a measurement of the likelihood of an event in a given sampling space. Generally, it reflects the frequency of the occurrence of an event. Let S be the sampling space and A be an event in S, which means A is a subset of S. Then the probability of A occurring is PA. So we will use big P to define probability of that event A is defined by number of outcomes in A over number of outcomes in S. So this is the formula of probability of event A. The probability of an event depends on the ways the elements are chosen. For example, in a contest, if we have 5 participants, we have to assume that each participant has an equal chance of winning. Therefore, the probability that a certain participant wins is 1 over 5. In statistics, we say that the selection of an element is random. It must be fair and not biased. If every element concerned has the same opportunity of being selected. The basic laws of probability: the number of outcomes in an event or a sample space is never negative. If nothing happened, or if we don't have any outcome of that event, still the number of outcome here is 0, and it is not a negative number, right? So if we refer back to our previous slide, and then from the definition of probability, we have this formula: PA is equals to NA over NS. And here A is a subset of our sample space S. Hence, we know that the number of outcomes of our event A is less than or equals to the number of outcomes in our sample space. Okay, so we have this interval, which is 0 less than or equals to NA, less than or equals to NS. And if we use this interval, all of each of the value here, if we divide it with NS here, okay, we will have the probability of A, because NA over NS is our probability of A, okay, is between 0 and 1. Include this values 0 and 1. Means when we're dealing with probability, the lowest value that we can have is 0 and the highest value that we can have is 1. Not less than 0 or not more than 1. Let's look at example 1. A bag contains 20 pebbles, 7 of which are yellow and the rest red. A pebble is selected at random from the bag. What is the probability that a yellow pebble will be selected? In this example 1, we can see that the sampling space S has 20 elements. Thus, we have NS is equals to 20. Let Y represent the event of getting a yellow pebble. So we have n y is 7. Now to find the probability, which is py, we use the formula of ny over ns, and our answer is 7 over 20. Now let's look at this example 2, where a fair die is thrown. Find the probability that the score is uneven number. So for this question, you have to make sure and don't get confused what is an even number and what is an odd number. So for the solution, we know that for a die, we will have, for the sampling, we will have 1, 2, 3, 4, 5, 6 as our outcomes. Hence, the number of our outcomes for the sample space is 6. And then let's choose a letter B to represent the event of getting an even number. Even number. And then our B will be either 2, 4, or 6. So for this event, the number of outcomes can be 3 outcomes. Hence, our probability that the score is an even number will be NB over NS, which is 3 over 6, and then simplify this answer, we will have 1 over 2. Example 3, a die is tossed. What is the probability of getting a number bigger than 4? So again, for the sampling space, we know we can get 1, 2, 3, 4, 5, or 6. Again, the number of outcomes for our sampling space is 6. And then let's choose a letter. So I want to use A to represent the desired event of getting a number more than 4. Then my A can be 5 or 6. Hence, I know that the number of outcomes for this event is equals to 2. hence the probability of getting a number bigger than 4, which is PA in this solution, is NE over NAs, that is 2 over 6. Again, if we simplify this, we will get 1 over 3. So now let's go to the last example, example 4. So here I will explain the video, the solution for this example. But first, let's look at the question. We have 3 fake coins are tossed. So what is the probability that exactly 2 heads are obtained? So in this video, for this kind of question, because here we have 3 fake coins are tossed. So first, for the sample space, let's have all the outcomes for our sample space. So first we have H, and then H, and then H, and then another outcome H, HT, and then we can also have HT, H, and then HT, T, T, H, H, and then T, H, T, 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 H, and the last one T, T, T. So these are all the outcomes for our sample space. So here we can see that the number of outcomes here is 8. 1, 2, 3, 4, 5, 6, 7, 8. So let's write that NS is equals to 8. So let's choose a letter. So I want to choose the letter B to represent the event of getting exactly 2 heads. Let's write that. So again, I choose a letter B for represent this event, getting exactly 2 heads. So let's list all the outcomes for event B. So we will have hash, hash T, and then we also can have hash T hash, and then T hash hash. So here we have 3 outcomes, hence the number of outcomes NB here is equals to 3. So to find the probability, now we just use the formula of NB over NS. So our final answer is 3 over 8. So example 4 concludes our first video. Let's have a little bit of rest time before we proceed to our next video for today.